Today's lesson is on events involving the words not and or. So first we're going to start with events involving the word not. Now if we know a probability of event E, we call P of E, then we can determine the probability that the event will not occur, denoted P of not E. We can say that the event not E is the complement of E. Now the sum of the probability that an event will occur and the probability that it will not occur is 1. So P of E plus P of not E equals 1. 1 is the probability of a certainty, right? So if we take a probability that it will occur plus the probability that it won't, then we're certain one of those two things is going to happen. Now if I solve P of E and P of not E, we can get these following formulas. The probability that the event will not occur is equal to 1 minus the probability that it will occur. The probability that event E will occur is equal to 1 minus the probability that it will not occur. So let's do an example. Find the probability of rolling a 2 on a 6-sided die. So there's only 1 2 on a die out of 6. Find the probability of not rolling a 2 on a 6-sided die. Well, instead of trying to figure out all of the things that it could possibly be, I can simply just take 1 minus the probability that it will occur. Now, we're going to be doing 1 minus quite a bit, so an easy way to turn 1 into a fraction so that we can add it into the fraction I really want is 6. So we can just make 6 over 6. You can multiply that by 6 if you really want to, but it's just going to be fast. If you want a denominator of 6, then 1 can be rewritten as 6 over 6. And it'll be really fast because we're going to be doing this a lot. So 6 over 6 minus 1 over 6, because the denominators are the same, the denominator stays the same, and the numerators add or subtract, in this case subtract. How about another example? Suppose a jar has 4 white marbles and 3 red marbles. Just as a note, that's total of 7 marbles. Okay? Find the probability of selecting a red marble. So probability of red is equal to the 3 possible reds over the total 7. So the probability of not selecting a red is going to be 1 minus the 3/7. Now again, we want to take the 1 and turn it into a fraction. I want the denominator to be 7, so 7 over 7 is an easy way of writing 1 with the denominator of 7. It's just always the denominator you want over itself, and that makes 1, and that gets me 4/7. Our next problem has the age distribution of U.S. moviegoers. So we have between the ages of 12 and 24, we have 900 from our survey. The ages between 25 and 44 is 1,080. Between the ages of 45 and 64 is 840. And then 65 to 74 is 180 from this particular survey, okay? So find the probability that the moviegoer is not in the age category of 45 to 64. So we're going to do this in 2 steps. First, we're going to find the probability that we are in the category of 45 to 64. So that is going to be 840 over 3,000. Now I believe that reduces. I can know it at least divides by 10 because the 2 zeros can be divided out. So that's 84 over 300. And I believe I can divide the top and the bottom both by 12. And that gets me 7 over 25. So the probability that if we choose one moviegoer is 7/25 if they're in that category of 45 to 64. But that's not the question asked. The question asks, what is the probability that the moviegoer is not in this category? So I am going to take the probability that they're not 45 to 64. I'm going to take 1 minus the probability that they are. The fast way of getting 1 to turn into a fraction with a common denominator of 25 is just 25 over 25. And 25 25/25 minus 7/25 is going to be 18/25, and that does not reduce. So that is your answer, 18/25. The next problem is a little tricky. Find the probability that the moviegoer is at least 25 years old. So at least 25, that means we're talking about 25 through 44, 45 through 64, and 65 through 74. So how can I use the not situation? Well, I know that the probability that the moviegoer is not 12 to 24 is the same thing as the probability is at least 25 years old. So if I can figure out what the probability of the moviegoer not being in the one category we don't want, then that will give me the category that we do want, at least 25. So everyone in this particular survey is over 25 except that one category. Now, in order to find the probability of not 12 to 24 years old, I need to find the probability that they are first. So I'm going to spend a little bit of time finding the answer to a problem that wasn't even asked because I need it to use it for the green part. So the probability that we have moviegoers between the ages of 12 and 24 is 900 over 3,000. Now this divides out evenly because the two zeros divide out real nicely, and I have 9 over 30, which reduces by 3, and I get 3/10. So the probability of not 12 to 24 is going to be 1 minus the 3/10 from before. That will also give us at least 25 years old. So I'm going to change the 1 into 10 over 10. And now that I got my denominators the same, they stay the same, 10, and my numerators subtract. So the probability that the moviegoer is at least 25 is 7/10, which is the same as what's the probability that they're not the one section that I don't want, 12 to 24.